Namaskar, Dr. Shaji. Welcome.
Thank you. I'm very happy to be part of this conversation yet again.
Thank you. So once again, congratulations. Last time we met for the Aditya mission, and now this ISRO's little master, EOS-8 Earth Observation Satellite that you have launched recently. If we can start with the significance of the satellite.
Sensors, normally it is that major application is to that forest fires or any change in temperature, volcanoes, the study of the volcano, how it is behaving, and the surface mineralogy. And also that's urban, if you see the urban heating islands we call, because when urbanization is becoming more and more, you can see a temperature difference compared to vegetation area. So that will be used for the infrastructure planning. And also this has a unique thing. It can differentiate cloud and ice, like not like other sensors. And also it can differentiate the flood and land, so that the flood, when you have the floods and the flood coverage can be seen. So these are all the major application which thought of are the IR payloads. And if you take the global navigation satellite system reflectometry, that mainly is for the major measurement it is going to do is soil moisture. So the soil moisture is an important parameter, because the soil moisture which gives you an idea about the surface temperature, atmosphere, the carbon cycle, the entire energy cycle, in a way that can infer the soil moisture, the drought condition, or it is going to be flood. All those conditions, this is an inference. With that, we can have a disaster management planned with this one. And one more important parameter, what it measures, the GNSS reflectment, ocean surface heights as well as the wind speed and the surface temperature. This will and the sea ice, all those things are very important parameters for our total weather and climate monitoring.
Can you explain what are the payloads on the Earth observation satellite and their functions?
Yeah, this satellite, actually it is a technology demonstration satellite, where if you take a satellite, there will be one bus system which is support the payloads. So we have all the new technologies both in the bus as well as the payload. And we have 3 payloads which are all our, maybe we can call it as a pilot payloads, which we will evaluate in this spacecraft. And further, this will be used for all the climate, weather, so many applications what it is required for. So that's one payload is IR payload. That's infrared sensor payload. It operates in the medium wave IR infrared as well as long wave infrared. It is a night and day. It can operate both in night and day. If you see the other sensors, visible light sensor, it can optical sensors. When you take only, it needs sunlight. The reflection of the sunlight, it measures and infers the data. Here it is just the radiation, the heat energy which is radiated from the earth will be inferred. So here it can operate both day and night. And other payload is GNSS receiver, that is Global Navigation Satellite System Reflectometry. That is what it, so these, just briefly I will explain these 2 payloads, what it does. This IR payload which senses the heat energy, like optical which senses the visible light reflection. This senses the IR, that basically heat energy it senses. And the other payload, what it does is, it's an active remote sensing. It's not an active remote sensing, but what it sees is, it receives signals from the global navigation satellite system like GPS or GLONASS, BIDO, and our own navigation, all those things. And also the GNSS signal which is reflected from the earth. So from based on these 2 signals, it infer lot of parameters on the earth as well as the ocean surface, and that will be used in turn for the many of the applications. And one more payload is the dosimeter, which is actually which measures or measures the radiation. It is mainly used by, it is a payload which need to be a must for Gaganyaan, where the human, when the human are exposed to radiation, we should know the what are all the radiation around. So for that, so it is as a pilot where we wanted to test before it is being flown in Gaganyaan. These are all the three payloads.
Space. So we will be able to know about, say, any such situations, any incidents like Wayanad or Kedarnath that happens instantly. We will have some signals prior to this incident happening, and so we can prepare for it.
Yes, yes. This is for the disaster management and emergency preparation. So with the surface height measurement, the sea surface height variation, and the soil moisture difference, with that we can infer all those things. And mainly the IR payload you can have for the forest fires. You can easily locate the forest fires and the area which is affected by the forest. And after the floods, also flood coverage can be estimated, and forest fire, the drought condition can be. These are all the things which can be estimated with this. And if you have a constellation of this, real time we can do it. And these are all the current trends with which the whole world, all over the world, they are operating with this type of payloads for all these applications.
Yes, of course. And like you're saying, this is going to, give us signals and let us know about the real-time happenings coming soon. What about the key environmental issues that EOS-08 will monitor, and how the data that we get from this will be used to improve the environmental policies, or how to, manage environmental issues?
It is one is that with the soil moisture thing, we can the vegetation areas, vegetation crops. That way, we can give the policy guidelines where the vegetation, and also infrastructure, urban planning where it is the crowding is there, and because of that, what is the environmental effects, the heating effects. That is, they call it urban heating islands. So where it is concentration of energy that can be inferred, and also the with the sea height variation, we can infer what is the going to be an environmental or the cyclone, whatever it is forming the cycle. See, these two are the parameters. One is the soil moisture and other is the sea surface height. These are all the two important parameters which define our environmental conditions and our climate cycle and how it is going to be, and so that we can give the policy guidance that how the wastelands whether can be used or like that.
When we talk about urban planning, one thing is the sustainabilities of the cities these days. What are we planning to going green, energy efficient buildings and things like that? So sustainability of the cities will be something that this satellite will help us with.
Yeah, definitely. Sustainability of the urban, that whatever the urban infrastructure sustainability will be the prime, because this IR payloads can infer the temperature and this crowding of this and the vegetation where it is less, the green cover is less, so that we can have a proper planning, so that we can have a sustainable urban infrastructure.
Yeah, of course. And the second thing that comes to our mind is that if EOS-08 has the capabilities to assist farmers and agricultural practices in predicting weather patterns will be possible in agricultural planning in managing crops and all.
Yeah, this can actually predict the water stress levels. So that way it will be very useful for the farmers and the agriculture, because the water stress means what? The leaves which evaporate the water by, and which is more than what the soil water what it gets. So that gives a temperature difference, and this can be inferred, and this water stress levels in all over the land can be mapped and predicted. So that way it will be useful for farmers and agriculture.
Okay, so now how we will be getting this data? Are there any sirens buzzing if there is a problem, or how you people will be getting the data, decoding it, and helping us to know about the calamities, the disasters, or anything related to agriculture or urban planning?
Yeah, this normally like other spacecrafts, our all the payload data will be downlinked at National Remote Sensing Center, Hyderabad, NRSA Hyderabad, and all this data will be downloaded. And with that, they have the data product. They have the data products processing and all the data processing, and they develop a lot of data products. And you can also public can also take the data from the Bhuvan portal, and we have the portal for you can mark the coordinates and they will be giving you the data, or they themselves will develop the data, and all this ISRO will be in touch with all the ministries. Many of the agriculture ministry, all the ministries are in collaboration with us, and they will be asking us the data required. So that way the data flow to the different ministries to take or aid them in their policies, and also disaster management, and also public or private, if they want this data can be they can request and get the data, and they can develop their own applications. So now, as you see now, ISRO has a policy more of a private, including the private people,
Players
private
as well.
partners. Yeah, so it's all free. The data is free, and it can be used. And we also have a separate data product section which develops products based on these things, and they will be helping all the ministries.
You in the beginning you talked about constellation of such microsatellites will be needed. This is just a pilot one. So when are we expecting more of such satellites so that we get more of such data and information?
Because now that after the space reforms, it's like we should get the requirements from the ministries and things, what the type of application they want, what is the type of observation they want. It's what the temporal resolution what they want. If they want real time, we need to have a more and more number of satellites for the constellation, or they want once in a day. So all those requirements depends on the users or ministries requirements. We can always design a constellation which can work for them.
There will also be a new domain for India, as there will be demand for microsats for Earth imaging and all. So do you think of propagating this in that field as well?
Yes, we are because this type of because the presently world is moving towards this microsat constellation. Even if you take Starlink, everything you take, it's all microsats constellation. So we are also moving towards that, and we are ready even to technology transfer this so that private parties can develop their own spacecraft, and they can launch it, and they can make constellation. So we are open for technology transfer, or any type of help what they require, a guidance, anything required, we are open for it.
Okay, anything else that you want to add to this whole conversation?
Yeah, this because as you media people, it has to be propagated well. So these are all the ISRO has the capability of all these things, so that more and more private and ISRO partnership will grow, and we will also contribute to the space economy, which is going to be significant in the coming years.
Okay. What next in your kitty that we are going to talk about in our next talk?
Next, we have immediately we have that our technology demonstration of space docking experiment, and that we have, because that is very essential for our Gaganyaan, either Bharati Antariksh Station or Gaganyaan station type, or all Chandrayaan 4 follow-on missions. The docking is a very important technology which is required. So on that, we are in the coming few months we'll be demonstrating that docking technology will be demonstrated. And also we have a regular our the joint collaboration with JPL, and because we have to rebuild our navigation satellites, so a lot of spacecrafts are in pipeline, so we need to do that, and
Okay.
it's our hand.
So we can promise our viewers that we'll be meeting soon with some good news from ISRO once again.
Yes.
Thank you so much for joining and giving us these essential insights. Thank you.
Thank you.